So most of you probably know GAMS as a software company. So GAMS is basically a standalone software where you can write your models as they would look like on what you would write in a paper. And then you can use this one formulation of your model and then just, change the solver with one line of code. So it's a solver-independent solution. What a lot of people don't know is that we're not only a tool provider, but we're also in a lot of research projects involved as a partner in industry, and we're also doing consultancy. And this is what I want to talk to you about today. And I named my talk the optimization pipeline, or mastering the optimization pipeline. And usually when I talk about the optimization pipeline, I talk about the different steps that are included in every optimization project. And every optimization project, you may also know this, starts with your data input. And you need to pre-process your data. You need to streamline your data into your model formulation, maybe switch the environment, and then pre-post process your results, and then put some visualization on top of that. But today, I want to broaden this picture and this perspective to give you an idea what is important in the optimization pipeline if you want to put your optimization model into something that a client actually also understands within a consultancy project. So what I want to talk about is the most common challenges in application development, in OR application development. Maybe this is also true for other applications. I want to emphasize and stress the role of prototyping. We've heard this today before, but I want to emphasize this even more. And then I want to talk about a little bit what it takes to actually transition a prototype into something that works with the client, so into a mature application. So let's start with the common challenges. Well, my first and the favorite challenge is the problem with communication. You may have seen this meme somewhere, but the main point here is, well, what the client tells you about a problem is maybe something like a swing here on the left. And then you talk to your team and, well, they design something and it doesn't quite look like what the client, described to you. But this is what your researchers, the OR people, understood from what the client told you. And then in the right, you see what the client actually needed. And this basically stresses the point, clients don't often know what they actually require, or they just don't know how to put it into words. So it is the problem with the communication. And to stress this even more, let's picture a common scene in working as a consultant in optimization, where we have an OR specialist. Let's call her Sarah. She specializes in mathematical optimization. So basically, this is all you. And then there is the client side. Let's call the client John. He's a supply chain manager, and he works at a retail company, but he's just unfamiliar with optimization. But he knows somehow he has a problem in his daily job that might be tackled and could benefit from some kind of optimization, but just don't know how. So this is why they talk. And now the first thing that happens in the usual way is Sarah starts to try to assess the problem because she needs to know what she has to model to cover, the problem of John. So she wants to know what the objective is. So she goes, to get started, I like to ask a few questions to understand your needs better. First, can you tell me what is your main objective? And for us as optimization people, it's kind of clear. She wants to know what he wants to minimize or maximize. What is the optimization goal, right? What is the objective function? But then there's John on the other hand, and he says, sure, the objective is to have just the right amount of inventory, just enough to meet our demand without overstocking. I just want the inventory to be balanced, not too much and not too little. So it's not really the answer Sarah was hoping or not was trying to get out of him. But it's the way that John understood it. And yes, maybe you can derive from that some kind of minimization or to maximize something, but it's not too clear. The next step is try to find out what are the business rules. And in our speech or in our language, this is trying to find out what the constraints are. So she goes, what kind of constraints do we need to keep in mind when we manage your inventory? To us, this is a clear question. We will probably kind of know what we would want the client to tell. But then John goes, well, one big constraint is that our suppliers are often late with the deliveries. Sometimes they say they deliver in a week, but it ends up 2 or even 3 weeks. This really messes up our inventory plans. So he understands the term constraint in a very different way than we intended it to, well, understand. And then the last question, I can go on like this forever, but then the last question is, so what are the key decisions you need to make in your inventory management process? So clearly it's the question, what kind of variables do we have? But John says, well, decisions. Well, yes, we have to decide things like whether to go with one supplier or another. That could be a hint to have some kind of binary variable here. Or if we should have a promotion to clear out inventory. Sure, from this you can also derive something, but it's not as clear as we wanted to have. So what is the main point? The main point is Sarah and John, well, they both speak English, but they don't speak the same language. Sarah speaks OR-ish, or mathematician-ish, and, well, John, well, he speaks client-ish. He just, well, and it's not the same language. And we can't blame John because he doesn't know what optimization is, and he also doesn't know what optimization is capable of. So he doesn't know what's actually relevant to Sarah. Often he tells things that are not relevant, like, well, our suppliers, they don't deliver on time. That's nothing that where optimization can help at John. Well, their optimization needs to help the supplier to be on time, but this is nothing John can actually figure out. And then the problem is John also owns his problem. And by owning, I mean, he knows this problem by heart. It's second nature to him. There are some points or some aspects he just doesn't think about because they're just second nature. And then Sarah, how should she know about it? And while up until here, I kind of blame John for not understanding the correct way. But actually, the main takeaway is it's not on him, it is on us. We have to leave our way of thinking, our way of, okay, what is the objective, what are the constraints, and what is the decision variables, right? It's on us as consultants to ask the right questions that are not out of the box, but they would be more natural to John. Maybe a better question is, how do you decide, or how do you do the inventory management on a daily basis? Can you give me a run through? And then you get a lot of stuff that's not relevant for the problem, but it probably answers the questions you have that answer the objective function, the constraints, and the decision variables better than by trying to squeeze John into this, well, frame that we've just seen. But it's not the only problem we have in consultancy. It's not only the communication problem. There's also the problem with, I call it the quote. So from experience of certain projects I've worked on, 80% of the work is done if you understood the client's problem. And by understanding, I mean you know what to minimize or maximize, you know all the business rules, you understand the business rules, and you know what decision variables you have. So that's 80% of the work. The rest, sure, there is still work to do, but I think that's like the essential point in every project. But understanding allows you then to estimate the time you need to put into this optimization project. And when you know how much time you need to actually work on this project, well, you can come up with a well-calculated budget with a quote for the client. But wait, if you need to understand 80%, or if you need to put in 80% of the work to be able to quote something and to actually give it to the client so that the client can decide, okay, this is something we want to do or not, well, it's kind of a problem if your client decides, I don't want to do that. So you've spent 80% and you're not getting any cent for the work you've done. Um, and what if all the questioning just annoy the client because they just want to get the project started? So there's you have to basically compromise on problem understanding to actually get the deal on board. And then it's just about keeping your fingers crossed that you did a good estimate and you're not ending up with the client expecting something like Game of Thrones, so it's super shiny, super cool application, but the project you quoted is only something like the game of pool noodles. And this is where prototyping comes into play. So to basically tackle the aforementioned problems, we try to squeeze every project at GAMS where we do consultancy into those 4 phases, where in the first place we do a kind of a feasibility study, see if we understand the problem, see what the client could need, and then there's this prototype phase where it is so important to give the client something that works, that they can kind of click around with, can play with, that they can relate with. Because if you remember, the client doesn't know what optimization is capable of. Once you give the client something to touch, to play with, it just becomes clearer what can be done, and then often requirements also change over time. Because then they figure out, oh, this is something I also wanted to do. Is that possible? And yes, often this is possible, but they just don't know up front. And we've seen this also today. So then there's like this prototyping phase where you go back. It's a fast forward loop. Go back all the time until then you've hit the final development stage. And in the end, the support phase, the long-term support phase. And this is the prototyping phase is where your optimization pipeline will basically gets the first time into the hands of the client. And the very important part here is the rapid prototyping. We've seen this, I think, we've heard this in the Siemens talk before. The client needs to have something rapidly, fast, so within the first 6 to 12 weeks. So basically, this approach helps you with the prototype to bridge the language barrier. Because with a prototype, now you can streamline the different languages of John and Sarah. While Sarah can still think about this in constraints and variables, the client now has something to touch, to play with, and it just bridges the gap because they now have something they can talk about. They can specifically point to something, say this is wrong or this feels off. And it shows what optimization is capable of. You know the relevancy of all the processes, and you also figure out what is wrong in your current implementation. Often we give the solution to the client, and then the client comes back and says, yes, but this is not a feasible solution. You forgot to, I don't know, take into account A, B, and C. Well, and then you go back, redo it over and over, and then you end up and have to be very, very well prepared for something that I call the try and error prototyping. So we're building a Lego car here, and I mean, not me, but someone on the internet, on YouTube, builds a Lego car. But I think it shows what actual development means, and also an OR project development. You build something which works. It's a feasible solution. You give it to the client, and the client says, there's something missing. So you go back into your prototyping phase, change the project, change the problem, and then it works again. And requirements change over time. And in the end, it's still a try and error approach. So prototyping is still a try and error approach, also in OR development. And one example I want to talk about where rapid prototyping really made a big change is scheduling physicians in a hospital. This problem is, well, there's a client, they are 60 doctors, 60 physicians at a hospital, and every one of the physicians, they have specific, well, uh, certificates, right? So not everyone can do pediatrics, not everyone can do cardiology and stuff like that. The number of physicians in a hospital is constantly growing, and they need to perform certain tasks every day. And not everyone can do those certain tasks. Also, not everyone works on a full-time basis. Some of them work on part-time. And then there's also something we call vacation or days off. So there's a certain availability. And then in the end, they need a feasible schedule on who is doing what task on which day. Well, subject to the tasks that need to be done and subject to the actual roles they can take over depending on their certificates. Well, and that's, well, it's a simple, or not really simple, but a standard optimization problem. But they also want this schedule to be fair. It shouldn't be just feasible, but it should be fair. And their current approach is they have one of the physicians taken off of work for 5 weeks every half year to actually come up with a feasible schedule. So that's very, very expensive. And that's why they reached out to us and asked if we can do something about it, if we can come up with a scheduling that's fair. And then we sat down and thought about, okay, so what could fairness actually be, and how can we communicate this to the client? So this is why we came up with something that we called pain points. And pain points basically refer to the pain you have to endure while you take over a certain task. So the usual 9 to 5 doesn't cause pain, it's just your job. But if you have to take on a certain responsibility that's more stressful, you get 1 pain point. If you have to stay overnight at the hospital, it's definitely more painful than the 9 to 5 daily business. And if this is going to be on a weekend, then this is even more painful. So this is why we gave them the chance to assign a different value of pain points for the different tasks in their schedule. And then the idea is that whenever you take on such a task, you kind of collect your pain points. And after or in one planning horizon, the idea is that all the bags with all the pain points should be equally filled. And then this is a certainly fair assignment. And it was kind of hard to talk about this to the client. This is why the rapid prototyping was so helpful, because we could actually give them a graphical user interface where they could change the roles, availabilities, the certificates, and all of that, and then compute a schedule where they can actually see how fair the assignment was. And what we showed them then is, well, here on the right side, this is your last 6 months. This is how your one guy, based on the pain points you now gave, came up with the assignment. So, and you see, it's a very up and down. It's not very fair. Whereas on the left-hand side, if we would have done this optimization, we would end up on the left side, where this is kind of like a very, very, well, fair assignment, because everyone collected the same amount of pain points. Well, except this one guy, but, well, he can only do this one job, sorry. And then with rapid prototyping, we also found that trying to match the product to something that the client already knows is super beneficial. So what you would see here is our graphical user interface. Like you see on the left, the people that I had to gray out here, but on the left are the people, and then you see the days and the planning horizon on the x-axis, basically. So it's kind of a calendar. And then everyone can look what kind of role I'm assigned to on which day. And this was actually something they gave to us in an Excel sheet. It looked exactly the same colors, the same names, the same abbreviations. And with us building exactly that into the optimization, well, visualization in the end, it was super easy for them to understand the solutions, to actually, yeah, relate to the solutions. Well, on the last point, sure, well, when you have done the prototyping phase, you need to transition from mature or from prototypes to a mature application. And yes, I have to be honest, this is something that is, well, super, super project specific, but there are certain key steps you need to take into account. So there should be a user interface that's really, really helpful, that needs to be, well, intuitive, right? It has to be streamlined. So the handling has to be smooth to actually have a mature application that will be used by the clients. Well, then you need to be kind of, well, sure on how you want to run this problem, if you want to do it on-prem or in the cloud or some kind of a hybrid one. So it needs to be a good choice here. So you not just pick randomly, but actually choose the right one. And kind of balancing what's right or judging what's right is not super easy. And then, of course, when we talk about clients and optimization, performance is key. We all can appreciate that solving a scheduling problem to optimality is hard, but the client usually does not have this appreciation on how hard it is. So if you have the client sitting daily, just only 30 seconds before you can prove optimality, it might not be the best solution for the client. So performance is key, and optimality or proven optimality not always key. And then, sure, the common challenges is still how do you integrate with existing systems? It's kind of hard. How do you manage data? Sure, even harder. Data is never clean. It has to be consistent and of good quality. And one key thing, try to catch user errors very early in the process. So if they put in something that from, well, just looking at it will produce an infeasible model because everyone's on vacation and then, nobody can take over the jobs, you need to kind of catch this early on. So this is very, very important to transition into mature application. And the fun part about the consulting exercise at GAMS is not only that it's fun, but it actually helps us in the product development, in the software product development, to identify missing features. Because from the insights from those projects, we can actually generate ideas of what is missing, and we can develop the features that the community needs and then make them available to the public. And the best thing, we stress test our problem or our software, because this is the most valuable feedback when we put our own software to actual real-world use cases. So what are the key takeaways? Well, the main takeaway for today is basically communicating OR solutions is not like selling a car. It's different. It's something people don't touch often, something that they cannot relate to super easily. I just feel it's a lot harder. Rapid and early prototyping is key. And tight feedback loops, as I said, in the prototyping phase, going back and forth, try and error, breaking the legal car, that is very essential. And that's it from my side. Meet me for cake, and thanks for your attention.